Hello, Physics Nation. My name is Nate Larmond. I like to do a Khan Academy problem from this set called Calculating Speed and Mass Using Conservation of Momentum. A 2 kilogram cart moving right at 5 meters per second on a frictionless track collides and sticks to a 3 kilo cart moving left at 3 meters per second. Oh, so we're playing chicken here. And nobody backs down. I always describe the scene from Footloose, but none of my students know Footloose. Anyway, we got one card going right and one card coming left. And like I said, nobody backs down. So let's see. We have M1 as 2 kilos, 2 kg, moving at a velocity of 5 meters per second. All right, so that's 10 kilogram meters per second. And this guy, M2, is 3 kilos, except this guy's not going as fast. So we have a small mass going a high velocity and a higher mass going a slower velocity. Well, 2 times 5 is 10, 3 times 3 is 9, so it looks like the light, fast guy is going to win the momentum battle. 3 kilos initially is moving. They use U for initial velocity for these problems. I don't know why. Let's see, -3. That's really important. You got to get these signs right for these momentum problems. All right, so for a sticky collision, an inelastic collision, that word right there means it's inelastic. Momentum is always conserved, but energy is not conserved in inelastic collisions. We just got to do m1v1 plus m2v2. That's the momentum before the collision equals the momentum after the collision. And two masses become one. That's the way I like to think of inelastic collisions. So we're just going to do m1 plus m2 multiplied by the final velocity. So this is how we express the final momentum in a sticky collision. You literally add the two masses. All right, so like I said, 2 times 5 is 10 kilogram meters per second, coming in with a positive momentum. And then 3 kilos times -3 is -9 kilogram meters per second. So the right moving guy wins. Slow and fast wins the momentum battle this time. Anyway, what is the sum of their two masses? 3 plus 5 is 8. 1 divided by 8 is 0.125. Like I said, positive wins. Here I'm doing a little too much algebra in my head. We would just do the sum of the two momenta coming in. There is more positive than negative. 1 kilogram meter per second is the net momenta entering the collision. So it's just 1 divided by 8, an eighth of a meter per second. But Khan isn't into fractions, so we're going to do 0.125 meters per second as their final velocity. What is that in decimal? 0.125. Oh, they want 3 sig figs. Okay, 0.13 meters per second. What? Uh, Hang on. The sum of the two masses. Oh, is not 8. The sum of the two masses is not 8. It's 2 and 3. It's 5. It's 1/5. Man, I am just on a losing streak. 0.2. Yikes. All right. Well, don't unsubscribe. Thanks for watching. See you in the next video.